Good morning, all the first year students. I am Principal APRJC Nimapur and also Economics Faculty Member in APRI Society. All the first year students already admitted in APR all colleges, but not classes started. So that our APR Society started a first year online classes also. So already taken classes to the second year students, online and offline. But today onwards, the economics classes started to all the first year students. Now, economics introduction started from in this college. Now, economics, the word comes from two Greek terms, oikos and nemo. These two terms is called, that means household management. But this household management, how can you earn an amount? And that amount is spent to various commodities for living conditions. So that is the economics in previous days. That is not a scientific manner. In scientific manner, Adam Smith, who was the father of economics, an inquiry into the nature and cause of wealth of nation in 1776, the economics is the wealth of nation. That is the definition of wealth of nation. So wealth means some assets. These assets either by gold or silver or houses or lands. So the definition relating to the wealth, that is called economics. This is defined by Adam Smith. And also not only wealth, but also the welfare is the human being is very important. And another important economist, Marshall. The Marshall definition, a welfare to the human being, that is very important. And another important, according to Robbins, the scarcity definition. What is the scarce? The resources are scarce, but wants are unlimited. Resources is limited, wants are unlimited. How can unlimited wants satisfaction with scarcity of resources? So that is the main problem. That economic problem can arise, wants are unlimited, resources are limited. That is the main problem of economics. So this here, especially 2020 March, this 30% of syllabus reduced in first year. That is wealth of definition, welfare definition, scarcity definition is also reduced from 30% of syllabus. But what type of definitions you will ask in the public examinations? That is a growth definition. This is the growth definition by Professor Paul A. Samuelson. What is the growth? A growth and development of each and every country with availability of resources. and natural resources or human resources. There are plenty of natural resources and the human resources available in our country, but may not be proper utilized. These natural resources. The allocation of resources is very important to all the factor production or a pricing of productions. That is the very important. So that is the growth is in any country the definition by a Paul Samuelson. But another definition, Jacob Weiner's definition. Jacob Weiner's definition. So according to Jacob Weiner, economics is nothing but economics is what economists do. What economists do. The economist, what duties, what are the functions to fulfill in our any economy. So what type of commodities to be produced? What type of commodities to be produced? How much of commodities to be produced? What size of commodities to be produced? How can this produced? To whom this commodities to be produced? How much of price can determine these commodities? So this is the economist to do. All the economists main functions in any economy, what type of commodities to be produced? What type of commodities produced? The people demanded of commodities. The people wants of commodities. The people demanded of commodities only produced in our country or any countries. So that is called Jacob Weiner's definition. Economics is what economists do. Okay, the wealth definition, welfare definition, and scarcity definition, and growth definition, and the Jacob Weiner's definitions of what economists do. These are all the definitions of economics. But in previously, according from Greek words, that is only household management. This is not a scientific manner. In scientific manner, the economics is defined by who was the father of economics, that is Adam Smith. In 1776 onwards till today, this all economics can do with scientific manner. So this is the definitions chapter. So this economics is divided into two types: microeconomics and macroeconomics. Economics divided into two types, that is microeconomics. Microeconomics. And second one, macroeconomics. Microeconomics and macroeconomics. First of all, microeconomics. A micro means a small. Micro means a small or a millionth part. A millionth part, a small part. Micro means a millionth. A micro means a small. An individual units. Micro means an individual units. Individual units. So what is the individual units? Suppose in the forest we study not entire forest, each and every plants we can study, that is called an individual. Suppose in our country 130 crores of the people, but entire 130 crores of the people cannot be studied in micro level. In micro level, each and every individual, each and every population we can study it. That is called micro. Okay, now we are going to a general definition of economics. Economics is nothing but economical activities of human being. Economical activities. Economical activities of human being. Economical activities of human being. That is called economics. So what are the economical activities? Production, consumption, exchange, and distribution. These four are the economical activities. What are the economical activities? Production, consumption, exchange, and distribution. These four are the economical activities. So, production. Without factors of production, we cannot produce commodities. The factors of production is very important. Factors of production. What are the factors of production? Land, labor, capital, and organization. Land, labor, capital, and organization is four are the very important factors of production. Without factors of production, either by land or capital or land or organizers. Suppose without land, labor, and capital, how can organize? So that the organizer, coordination of land, labor, and capital, they can produce more commodities with the help of factors of production. So this is called a production. And consumption, so we can consume and directly satisfied of our wants, that is called a consume or consumptions of goods, either by consumption goods or capital goods or product goods. This product goods produce another commodity, that is called product goods. Either by consumption, directly we can satisfy of our wants through commodities or goods, that is called a consumption. And third one, exchange. In previous days, exchange means one commodity exchange to another commodity. But here, the price is in between one commodity to another commodity. That means the commodity can exchange into the price level. That is called exchange. So that in modern days, the price is always very important. The price mechanism, the entire economy around the price mechanism. So that is the exchange. And last one, a distribution. What are the distribution? Suppose these factors of production can receive some amount from land. Land rewarded to the, how much an amount? That is a rent. Rent rewarded to the land. Rent rewarded to the land. And labor, that is a wages. Wages rewarded to the labor. And interest rewarded to the capital. And profit is rewarded to the organizer. So this is called a distribution. This production, consumption, exchange, and distribution, these four are the very, very important and economical activities. This entire syllabus include in this sentence, that is the economical activities of human being. Okay, now we are going to microeconomics and macroeconomics. Micro means a small or a millionth part, a small part, a millionth part, or an individual part. So this microeconomics studied on an individual income, an individual income, and individual savings, and individual farm production, and individual commodities, and individual, each and every an individual studied in microeconomics. Suppose in macroeconomics, macro means a large, aggregate, or total, or a big. This is called a macro. Macro means a large, a macro means an aggregate, or a total, or big. So that is as a whole. Macroeconomics studied as a whole. As a whole. That is a total study. Suppose, for example, in microeconomics studied an individual income, a person income, one person, my income, your income. So that is called an individual income. But in macroeconomics studied a total people income. Total people income means a national income. National income. The national income means a total person's income. So next class we will start a national income, a real output of goods and services with a multiple with price of marketing level, that is called a national income. But the national income only studied in macro level, but not micro. In micro level and individual incomes, each and every person of income can study it by microeconomics. But in macroeconomics, entire people, that is a total people of the income, that is a national income. A C plus, I plus, G plus, X minus M, that is a gross national income. But net national income, so another class in national income chapter, we can prepare or study it in C plus, I plus, G plus, X minus M. Okay, so this is the microeconomics and the macroeconomics. Microeconomics is also known as a price theory. Microeconomics is also known as a price theory. A price of factors prices, or marketing prices, or pricing of various commodities in the market, or price of various factors, that is a land, labor, capital, and organization. The land, so that is a price given to the land, that is called rent. The price, some price given to the labor, that is called wages. Some prices given to the capital, that is called interest. That's almost all is very important. This price includes in profit also, the profits given to the organization. So that is called a microeconomics. A microeconomics, an individual income, an individual savings, an individual production, an individual firm equilibrium. Suppose in microeconomics study a firm equilibrium, firm equilibrium. But in macroeconomics, an industry's equilibrium. Industry. So what is the difference between firm and industry? So all the firms then get together, that is called industry. Sugar industry, jute industry, cement industry. So a number of firms producing of a sugar, this is a firm, A firm, B firm, C firm. A to Z firms can produce sugar, that is called an individual firm can producing the sugar In economy, that is called a micro level. But in the industrial, all the firms can get together. That is called a macro level. That is industries. So, macroeconomics studied industry equilibrium, but in microeconomics studied a firm equilibrium. So that is the difference between microeconomics and macroeconomics. So the microeconomics and macroeconomics both are important. Suppose in micro level we can study microeconomics. Suppose our government, how can the allocation of resources to all the people, either by rent or either by wages or either by distribution of in any level or wealth. Suppose our wealth and income can equal distributions to all the people, no problem. But this problem can arise a two classification. One is poor and another one is rich. Why rich and poor can classifications in our economy? Not equal distribution of income and wealth. This income and wealth cannot be equal distribution to all the people. They can arise rich and poor. The two classifications can arise in each and every society or any economy. Any economy can two stages is very important. So that this is a very important economics studied, that is a micro level. Suppose a macro level is also the total employment, a national income, or aggregate output, a total output. We can produce how much on output in 2020-21. So this is the $300 million. Suppose 300 quintals, or suppose the 400 million of tons producing of agricultural commodities in 2019 and 2020, or 2018 to 2019, how much can produce in agricultural sector? And 450 millions of tons can produce each and every commodities in agricultural sector. That is a macro level. Okay, can understand micro and macroeconomics. And another very important concept. What are the difference between microeconomics and macroeconomics? Difference between microeconomics and macroeconomics. This is very important question. We'll ask in the public examination also. Microeconomics and macroeconomics. What is the micro and macroeconomics? Micro means a small or an individual. Micro means a small or an individual units. That is a micro. And macro, aggregate or total or large or big. So this is called a macroeconomics. And second one, microeconomics is studied an individual units. An individual units. An individual income, individual savings, one commodity price, one firm equilibrium. So these are all the microeconomics studied and individual units. But in macroeconomics, aggregate, that is called a national income. Total output. So this is the macro level. And the third one, microeconomics is also known as price theory. Microeconomics is also known as price theory. But the macroeconomics, income and employment theory. Income and employment theory. Income and employment theory. Microeconomics is also known as price theory, a price of factor prices, a price of an individual commodities, a price of an individual markets in commodities. So these are all the importance of microeconomics. But in macroeconomics, income, a national income, a employment, a total employment, total output, total savings of any economy in the world. So that is called a macroeconomics. And fourth one, macroeconomics explains price determination under commodity and factor market. Under commodity and factor market. Commodity and factor market. Factor market. In the macro level, aggregate savings and general price level and economic growth. General price level. General price level and economic growth. General price level and economic growth. So this is the difference between microeconomics and macroeconomics. Price determination under commodity. Various commodities can price, both demand and supply can determine the prices under various markets. And factor prices, the price determined various factors, land, labor, capital and organization. Through rent, wages, interest and profit. So this is the price determination under factor market. Oh, here a general price level, aggregate demand and aggregate supply can determine this general price level. And that is the fifth one, microeconomics, which price mechanism. This price depends on demand and supply. Demand and supply. Both demand and supply can determine the prices in perfect competition market or monopoly market and duopoly and oligopoly. In any market, the price can determine under demand and supply only can determine the prices in any market. But here, the macroeconomic study, that is the aggregate demand and aggregate supply. Aggregate demand, a total demand, a total supply, that is the aggregate supply. Aggregate demand and aggregate supply can determine of macro levels. So this is the 5 is the very important differences between microeconomics and macroeconomics. Okay, first of all, various definitions of economics and classification of economics, microeconomics and macroeconomics, and their importance and what are the difference between microeconomics and macroeconomics. And entire introduction of first chapter, some of the 30% of syllabus reduced a deductive method and inductive method and positive method and normative method. These 4 methods are also reduced in your first year syllabus. The first, wealth definition, and scarcity definition. These definitions 3 and also normative and positive, deductive and inductive methods are also reduced in your first year syllabus. Now we are going to goods. The goods are divided into 2 types, free good and economic good. Free goods divided into 2 types, a free good and economic goods. Economic goods. Free goods and economic goods. Free goods and economic goods. What do you mean by free goods? The goods which have no price, that is called free goods. Which have, these commodities are not, these goods have no price. Have no price. That is called free goods. But economic goods which have price, the price of goods, price of commodity. These goods are having prices, but that is called economic goods, and free goods which have no price. Why? The supply is more than demand. The supply is more, a plenty of supply. The more supply is in any economy, the commodities have no price. Suppose a grass or water or air or sun rays. So these are all the free goods. Why? Because each commodity have no price. But sometimes this goods is also prices. That is the economic goods. Water. So this bottle, 1 liter bottle and 10 rupees and 15 rupees we have to purchase. So that commodities we can purchase with price. That water is also sometimes economic goods. But the supply is more than demand. So that these goods are called as free goods. These goods are free goods. Oh, these goods are economic goods. So these free goods divided into two types. Consumer goods. The goods, these economic goods are divided into two types. Consumer goods and product good or capital good. Product.
So there are certain models, there are certain issues which can lead to Welcome to the class today. Topic is developments leading to the Bohr's model of an atom. Okay. What are the developments are leading to the development of the Bohr models? So there are certain models. Welcome to the class. Today topic is developments leading to the Bohr's model of an atom. Okay. What are the developments are leading to the development of the Bohr models? So there are certain models, there are certain issues which can lead to the development of the Bohr model. Okay, we know from the previous classes, we know Rutherford model has some drawbacks. So there is some, after that there is some experiments, then some theories are leading to the development of the Bohr model. What are the experiments, what are the theories can leading to the development of the Bohr model? Okay, Bohr model is developed on the basis of drawbacks which as we know from the Rutherford nuclear model. Then from the drawbacks, okay, and from the note of the drawbacks and from the this type of experimental data and theoretical data which can lead to the development of the Bohr model. Okay, what are they? First one is dual character of the electromagnetic radiation. Dual character of the electromagnetic radiation, which has wave-like and particle-like properties. Okay, electromagnetic radiation have both wave-like and particle-like properties. Okay, we know electromagnetic radiation. Okay, electromagnetic radiation has wave-like and particle-like properties. Okay, this is the one which can help the development of the Bohr model, and also experimental results regarding atomic spectra which can be explained only by assuming quantized electronic energy levels of an atom. Okay, experimental data results regarding atomic spectra. Okay, from the experiment we know atomic spectra. Okay, laterally we know atomic spectra. Experimental results regarding atomic spectra which can be explained only if the atom has quantized energy levels. If the atom has quantized energy levels, then only we can explain the atomic spectra. Atoms can give what is means of atomic spectra? Atoms can give the atomic spectra. Okay, which was explained by assuming atom has quantized energy levels. Then only we can explain this. So based on these two concepts, dual character of electromagnetic radiation and atomic spectra. Okay, atomic spectra and dual character of the electromagnetic radiation. These two topics were mainly leads to the development of the Bohr model. Okay, how Bohr model is developed is based on these two concepts. They were developed the Bohr model. Okay, experimental dual character of the electromagnetic radiation means electromagnetic radiation has wave-like and particle-like properties. Okay, next experimental results of atomic spectra. Okay, experimentally we know atomic spectra we can get it from the atoms, then which can be explained by assuming quantized energy levels of an atom. Okay, one by one we look into the this type of concepts. Let us look into the matter dual character of the electromagnetic radiation. Okay, how we can explain dual character of the electromagnetic radiation. Now let us focus wave-like properties of the electromagnetic radiation. Then we also look into the particle-like properties of the electromagnetic radiation. Okay, now we want to discuss in detail the concept of wave-like properties of electromagnetic radiation. How the electromagnetic radiation behaves as wave. Okay, how we want to know how electromagnetic radiation behaves as wave. We know what is the means of electromagnetic radiation. First of all, electromagnetic radiation, we know the light can emit, any light can emit electromagnetic radiation. These are the electromagnetic radiation. Sun is also emit the rays. These rays are also electromagnetic radiation. The sun emits the electromagnetic radiation. Our tube lights, our bulbs, all are emits the electromagnetic radiation. So these electromagnetic radiation have both properties, means wave-like properties and particle-like properties. Okay, let us look into this one by one. How electromagnetic radiation has wave-like properties first of all. Then we look into the another type of property, how electromagnetic radiation has particle-like properties. Okay, wave nature of electromagnetic radiation. Wave nature of electromagnetic radiation, how the electromagnetic radiations are generated. Okay, from the Maxwell point of view, oscillating charged particles generates oscillating electrical and magnetic fields which are perpendicular to the wave propagation are known as electromagnetic radiation. Electromagnetic radiation is created by oscillating charged particles. Oscillating charged particles can create the electromagnetic radiation. Those electromagnetic radiation can have oscillating electrical and magnetic fields which are perpendicular to the wave propagation. Okay, electromagnetic radiation is created by the oscillating charged particle which has electrical and magnetic components are perpendicular to each other for the propagation of the wave. Okay, these two electrical and magnetic component, oscillating electrical and magnetic components are perpendicular to each other. Okay, one is in y direction, one is on z direction. This is in this way and this is perpendicular. These two, okay, this one and this one, okay, these two has, okay, how can you say, these two, this wave and this wave, these two have 90 degrees. Okay, they are perpendicular to each other for the propagation of the wave in x direction. One of the component in y direction and another one of the component is in z direction. So one is electrical component or electric field, another one is magnetic field component. Okay, these two are propagating. So this wave is known as electromagnetic wave. This wave is known as electromagnetic wave. Electromagnetic wave can pass through the vacuum also. Okay, it does not require any medium. Electromagnetic radiation does not require any medium like sound waves and water waves. They require medium for their transmission, but electromagnetic radiation does not require any medium. This can pass through in vacuum also. Okay, they can pass through vacuum also, or electromagnetic radiation does not require any medium. Next point, there are different types of electromagnetic radiations. There are different types of electromagnetic radiations in the nature. Okay, these are closer together. Okay, we can study these together, is known as electromagnetic spectrum. Okay, electromagnetic spectrum means a different electromagnetic radiations are come together, they can form the electromagnetic spectrum. Okay, electromagnetic spectrum consists of different electromagnetic radiations. Electromagnetic spectrum consists of electromagnetic spectrum consists of electromagnetic spectrum consists of electromagnetic spectrum consists of different electromagnetic radiations. Electromagnetic radiations. Okay, there are different types of electromagnetic radiations. Okay, these are come together, is known as electromagnetic spectrum. Okay, different types, we know electromagnetic spectrum has different types of electromagnetic radiations. These electromagnetic radiations are characterized by certain features, are known as electromagnetic radiations are differed by certain properties, are known as wavelength and wave number, frequency. Like these properties are variation to the one type of electromagnetic radiation and another type of electromagnetic radiations. So finally we can say electromagnetic radiations are one another differ by these type of properties are known as wavelengths, wave number and frequency, like that properties that differ to one electromagnetic radiation to another electromagnetic radiation. Now look into the that concept. What is the wave number? What is the wavelength? What is the wavelength? What is the wave number? What is the frequency? Okay, let us know it. The wave characteristics means electromagnetic waves are characterized by certain properties. Electromagnetic waves, we know electromagnetic spectrum. Electromagnetic spectrum consists of different types of electromagnetic radiations. Electromagnetic spectrum consists of different types of electromagnetic radiations. These electromagnetic radiations one and each other differ by certain properties. The properties, let us know that properties. Frequency. Okay, what is the means of frequency? Wavelength and wave number. Okay, these are the properties and which can differ one electromagnetic wave with another electromagnetic wave. Okay, what is the meaning of frequency? Frequency is defined as number of waves that pass through a given point in 1 second. Number of waves. One wave means, we know this is known as one wave. Okay, this is known as one wave. Okay, one wave. Okay, known as one wave. Number of waves pass a given point in 1 second. This number of waves can pass a given point in 1 second. Okay, number of waves pass a given point in 1 second. In 1 second, number of waves can pass through a particular point. How many this type of waves can pass through that point in 1 second are known as frequency. Units, Hertz. Units, frequency units are Hertz. Next, wavelength is lambda. This symbol is known as lambda. Defined as the distance between two nearest crest or nearest trough. What is the meaning of it? Okay, distance between two nearest crests. These are the crests of the wave, the higher part. Okay, the distance between two subsequent crests or distance between two nearest troughs. Okay, this is means lambda. Okay, this distance between these two or distance between these two is known as wavelength. Okay, known as wavelength. Next, wave number. Wave number is indicated by nu bar. Okay, this is nu bar. There is a symbol like this, bar, nu bar. It is reciprocal of the wavelength. Okay, it is reciprocal of the wavelength. Reciprocal of the wavelength is known as wave number. Reciprocal of the wavelength is known as wave number. Okay, units is centimeter inverse, comma meter inverse. Okay, in CGS centimeters, in SI units meter inverse. Okay, these are the units they are used. Next, velocity is indicated by C. Velocity of wave is defined as distance covered by wave in 1 second. Distance covered by wave in 1 second is known as velocity. Okay, nu is equal to C by lambda. Okay, nu is equal to C by lambda. C is velocity of light. Is known as velocity of light. C is velocity of light. Velocity of light. Okay. C is velocity of light. Next, amplitude. Amplitude is indicated by A. Amplitude of wave is defined as height of crest or depth of the trough. Height is defined as amplitude is defined as the wave is defined as the highest crest or depth of the trough. Okay, we know the wave. The height of the crest or of the depth of the trough is known as amplitude. Amplitude is one of the criteria of the wave characteristic. Okay, one type of electromagnetic radiation has certain type of amplitude, and another type of radiations have another certain type of amplitude. So amplitude is differ from one electromagnetic radiation to another electromagnetic radiation. Okay, velocity also depend on the electromagnetic radiation, what certain type of electromagnetic radiation, certain type of speed they have. Okay, this is known as electromagnetic spectrum. In electromagnetic spectrum, with help of wavelength and frequency, you can differ one electromagnetic radiation with the another electromagnetic radiation. Okay, lambda, wavelength. Lambda means wavelength. Okay, wavelength. With respect to wavelength, radio waves have greater wavelength. Larger wavelength, 10 to the power of 8 meters. Wavelength decreases. This becomes radio waves. And then microwaves, 10 to the power of minus 2 meters. IR waves, 10 to the power of minus 4 to 10 to the power of minus 6. And next, visible spectrum. Visible spectrum in between UV and IR radiation. Visible radiations, visible spectrum or visible radiations contains in between UV and IR. This wavelength is in between these two, 10 to the power of minus 8 to 10 to the power of minus 6. It contains visible spectrum. Visible spectrum contains violet light, indigo, blue, green, yellow, orange, red. VIBGIRO. VIBGYOR. This is known as visible spectrum is in between IR radiation and UV radiation. Next after UV radiation, you go to the next X-rays. X-rays have very shorter wavelength. Then compared to this one, wavelength is very lesser. Compared to this one. And then gamma rays. Gamma rays have wavelength very much shorter than the 10 to the power of minus 10. It is a 10 to the power of minus 12 to 10 to the power of minus 18. So wavelength is very much shorter. Next, with respect to frequency, frequency is higher for gamma rays than X-rays than UV radiation, 10 to the power of 16. Whereas the frequency is gradually decreases from left to right. Left to right, frequency decreases. But the energy, which one is more energetic radiation? This one. Gamma rays are more energetic radiations than X-rays, then UV, then visible, then IR, then microwave, then longer radio waves. So, most energetic radiations are this. So, energy of radiation is proportional to E is equal to h mu. Energy is proportional to the frequency. Which one is more energetic radiation? Gamma rays, then X-rays, UV, visible, IR. like that. Okay, next, which one have greater wavelength? Okay, greater wavelength, that one, longer radio waves. Radio waves have greater wavelength, but these have shorter wavelength. Shorter wavelength and greater frequency is indicate stronger radiations. Okay, energetic radiations. This one, then compared to this one and this one. This is known as electromagnetic spectrum. Okay, different types of electromagnetic radiations are come together, then we call it as electromagnetic spectrum. Electromagnetic spectrum is how it is built. There are different types of electromagnetic radiation. These are come together. The whole, this one is known as electromagnetic spectrum. Welcome to the class. Today topic is particle nature of electromagnetic radiation, Planck quantum theory. Before we going to this concept, in previous class we know electromagnetic radiation has dual character or dual nature. Okay, on that context, electromagnetic radiation has wave-like motion or wave nature. Okay, why we say it has wave nature? Okay, because electromagnetic radiation can show interference and diffraction. So then it is it is called it as electromagnetic radiation shows wave nature, like wave-like properties. Okay, because of those two terms, electromagnetic radiation has wave nature, then we say that electromagnetic radiation has wave-like nature, because of they show interference and diffraction. Interference and diffraction Okay, because of these two properties, electromagnetic radiation can show interference and diffraction. So if any radiation shows interference and diffraction, then that electromagnetic radiation has wave-like properties. Then we call it as that electromagnetic radiation has wave nature properties. What is the means of interference? Interference means this is we take a wave and another wave, then mixing these two, there are two possibilities. These two are, this is known as interference. This is not constructive interference. Waves are constructive. One is mixed with the same phase. One wave is mixed with the another wave with the same phase. Then it is known as constructive interference. Constructive interference. If these two are mixed together in out phase, then it is known as out phase means this one and this one. This is known as destructive interference. Destructive interference. Okay, this is the way interference occurs. Next, what is the means of diffraction? Diffraction means bending of light, bending of the wave. Okay, when it strikes on the any surface, it shows bending nature. Then bending of light is known as diffraction. If any radiation shows interference and diffraction, then we call it as that radiation has wave-like properties. Okay, particle nature of electromagnetic radiation. Particle nature of electromagnetic radiation, Planck quantum theory. Okay, what it says. Okay, let us focus this concept. Okay, what is the means of Planck quantum theory and what is the meaning of particle nature of electromagnetic radiation? Okay, let us look into these topics. Okay, why particle nature of electromagnetic radiation, Planck quantum theory. Okay, electromagnetic radiation does not electromagnetic radiation, we know electromagnetic radiation has wave nature. Okay, electromagnetic radiation from the previous history we know electromagnetic radiation has wave nature. Okay, with the concept of wave nature, it cannot explain these type of experiment results. So what are the experiments? The nature of emission of radiation from the hot bodies. The nature of emission of radiation from hot bodies, that is black body radiation. Black body radiation concept is not explained by the wave nature of the electromagnetic radiation. Is not explained by the wave nature of the electromagnetic radiation. And also ejection of electrons from the metal surface when radiation strikes it. That is known as photoelectric effect. This type of practical is also not explained by the wave nature of the electromagnetic radiation. And then variation of heat capacity of solids as function of temperature. This type of experiment also is not explained by the wave nature of electromagnetic radiation. So it is another way means particle nature of electromagnetic radiation is introduced by the Planck quantum. Okay, particle nature of electromagnetic radiation is introduced by the Planck quantum. Planck quantum has assumed electromagnetic wave has particle nature. With this concept, he was succeeded to explain nature of emission of radiation from hot bodies. Okay, and then ejection of electrons from the metal surface, and then this one. Okay, these three practicals are explained by the theory of Planck quantum theory. Okay, Planck quantum theory is based on particle nature of electromagnetic radiation. Okay, he was succeed to explain these practicals, but the classical way means wave nature of electromagnetic radiation does not explain these these experimental data. Okay, these experiments are not explained by the wave nature of the electromagnetic radiation, and this theory, these practicals are explained by the particle nature of electromagnetic radiation is introduced by the Planck quantum. Okay, let us look into this concept in detail. What is what and what is the main object? Okay, how he was succeeded to explain nature of the emission of the radiation from hot bodies, and next ejection of the electrons from metal surface. Okay, in atomic structure concept, we only consider these two concepts. We can explain one by one the nature of emission of radiation from hot bodies. Then we go to this one. These two are in our syllabus. We only focus these two concepts, experimental details, in detailed explanation in this atomic structure concept. Okay, this is not present in your syllabus. We may in your syllabus there are two topics are covered in detail: the nature of emission of the radiation, black body radiation, and ejection of the electrons from metal surface, means photoelectric effect. Okay, let us focus. Okay, in 10th class textbook also there is one concept, that is, when if we take a metal rod, when we take a iron rod, suppose taken as a iron rod, if you take a iron rod and heated it, then heated up, then it color changes to initially it is in red color, okay, red color, and then it may changes to orange, and then if you heat continuously, then it changes to white, and then again you heat, more heat can pass through this one, it can turn into blue color. It turns into blue color. Okay, the experiment is, when you take an iron rod, is heated up, then initially it becomes red, and then it turns to orange, and then after some time, after heating, goes on heating, it goes to white color, and further heating you can get the blue color of the metal. Okay, what it indicates, it means why we are seeing orange color, red color, white color and blue color. Okay, because if you eat the any metal rod, any iron rod, suppose it has a metal iron rod, and on heating it can emit the radiation, which can emit the radiation. The emitting radiation has red color. Okay, radiation has red color, and then if you heat, if you given the more amount of temperature, more amount of heat, okay, temperature or heat, if you are given the higher heat, then it appears the orange color. Then if you more heat you can supply, then it can turns into white, and then it simultaneously turns into blue. Okay, what do we understand? The metal emits red color radiation. Here, after some time, on again continuous heating, it can emit the orange color, and then white color, and then it emits the blue color. Okay, blue color radiation. So temperature increases. What we understand? Temperature, when temperature increases, okay, temperature increases, okay, wavelength, temperature increases, wavelength decreases, temperature increases, wavelength decreases. Okay, this has, red light has longer wavelength, okay, orange, white, it has shorter wavelength, longer wavelength to shorter wavelength. We know from the previous electromagnetic spectrum, okay, which color has greater wavelength, which color has shorter wavelength. So temperature increases, wavelength decreases. Okay, from this point of view we know temperature increases, lambda decreases. Okay, lambda value decreases. Lambda value for blue color is very low, then compared to red value, red color has greater lambda value, and then we also know from this experiment, temperature increases, then intensity is also increases. Intense means intensity. Intense means brightness. Okay, brightness is also increases. Temperature increases, intensity is also increases. Okay, intensity is also increases. Okay, wavelength decreases and intensity increases. Intense colors. Okay, intensity is increases. Temperature increases, intensity is also increases. From this point of view, you can understand these two. Okay, from this experiment, an iron rod heating, it becomes to initially it is red, and then again on heating you can get the orange color, and again on heating you can get the white color, and again on heating you can get the blue color. Okay, blue color. Okay, from this point of view, temperature increases, lambda value decreases, and then temperature increases, intensity of the radiation is also increases. Okay, we may have some questions or doubts regarding this one. Is if you observe red color initially, then you may have some doubts. Okay, only red color radiation will come out of the metal rod? Okay, no. Okay, no. Why we say that? There are innumerable number of radiations will come on heating. Any metal on heating, initially it shows the red color. Okay, initially shows the red color. The metal has different radiation which emits the different types of radiations, red color, blue color, whatever may be the colors. But the dominated color is red color. Okay, one color is dominated, one color is intensified. That is the red color. Okay, initially if you are starting to heating a certain metal, it can emit so many radiations. But red color is the dominated one. Then we can call it as a metal initially shows the red color. And then after some time, you may again heating, you may observe orange color. Shall we call it as a metal can shows only orange color radiation? It can emit only orange color radiation? No, it can emit so many radiation, blue color, red color, white color, whatever it may be. But the orange color here is the dominated one. The dominated one will be, you can observe. Okay, you may take any other example for this one. Okay, dominated personality will be focused. Okay, remaining will be drop out or fade out. Okay, if you take milk and add some more bananas or apple or whatever may be the pieces you can add for the milk juice or like that. Okay, if you had more apples, then the flavor is apple flavor. Okay, that is the reason why the more intense color is orange, so we can appear the orange color. That is the same way here also. Here also the blue color is the dominated one. Remaining colors will be fade out and very little, and then the blue color is intense because it has the more dominated one. That is the reason after greater heating you can get the blue color. Okay, this is the point of view you can understand. Next, what is the means of black body? What is the means of black body? Okay, black body is a imaginary concept. Black body is not an exist, it is an imaginary concept. What is the means of black body? Black body, okay, I may write like this. Black body in platinum metal, take it as a platinum metal, is coated with carbon black. Okay, platinum metal is coated with carbon black, carbon CaRBan carbon black is coated, is COATD coated and platinum. Okay, platinum. What is the importance of black body? Black body is an imaginary one which cannot be exist reality. Okay, which can absorb all the radiation. If you pass any radiation, that radiation will strike here and then it will goes like this, and perfectly it is absorbed here. Perfectly it is absorbed. Any radiation can pass through this body, it is absorbed totally. And then if you heat this one, whenever you heat the black body, it can emit all the radiation which is absorbed previously. Okay, which is the perfect body which can absorb the radiation and simultaneously on heating it can emit the radiation. Okay, that is the importance of the black body. Okay, that is the importance of the black body. Okay, let us explain one graph. This is very important for the Planck quantum theory concept. Okay, this is an experiment. In this experiment they are taken intensity in y axis and lambda in x axis. Okay, in this regarding, at lower temperature, intensity of the radiation increases for a black body. If you are taking black body concept, at lower temperature, intensity of the radiation, emitted radiation is emitted or absorption. But if you are taking it is emitted radiation, black body radiation. Okay, at T1 temperature, intensity of the radiation increases. It reaches to the maximum and then starts to decreases. Okay, so intensity increases with decreasing lambda. Lambda goes to the lower value, shorter lambda value, and reaches the maximum and then starts decreases. If you increase higher temperature for a black body, then it is also intensity increases and reaches to the maximum and then starts intensity decreases. And the lambda maximum goes to the shorter wavelength. Then compared to this one, it goes to the shorter wavelength. Lambda maximum goes to shorter wavelength. And if you take another temperature, it is very higher temperature. T3 is greater than T2 than T1. So T2 is higher temperature and then T3 is very high temperature. Then also intensity of the radiation increases and then starts decreases. And it moves to left hand side. Lambda maximum moves to the left hand side. Okay, temperature. If from this graph we can understand that temperature is inversely relation to lambda. This is Wien's law. Okay, which is, you may read it in physics. Okay, temperature and lambda are inversely proportional. Okay, at lower temperature, this is the lambda. If you increase the temperature, lambda value decreases, and further increases, lambda value further decreases. Okay, this is the way you can found initially. We know if you start an iron rod, then temperature increases from red to, it turns to initially red and then white and then orange, then white and then blue color changes. Okay, which is also increases, temperature increases, lambda value decreases. And then from that point of view, you may know temperature increases, intensity is also increases. Intensity, what is means of intensity? Intensity means thickness or brightness. Okay, brightness is known as intense color. Okay, pale red, intense bright red. Okay, what does it mean? Bright red means intensity is increases. Okay, that is the reason, right? Intensity means what is the means of intensity is brightness. Okay, brightness of that color is known as intensity. Okay, let us explain this one. This is the practical experiments data. It comes from the practical. Okay, from the practical data which is not explained by the wave nature of the practical. This practical data is not explained by the wave nature of the electromagnetic radiation. This practical data cannot be explained by wave nature of the electromagnetic radiation. So then a new concept is derived by Planck quantum theory. This is known as Planck quantum theory. Okay, he can explain this concept. He assumed the radiant energy emitted or absorbed by a body not continuous but discontinuous. Okay, discontinuously in the small discrete packets of energy, and these packets are called quantum. Okay, the first statement itself is indicate this theory. The radiant energy emitted or absorbed by a body. Okay, radiant energy is absorbed by a body, not continuous but discontinuously in the small discrete packet of energy. These packets are called quantum. If you hit the black body, then it can emit the radiation in discrete. Okay, discrete means packets of energy, not continuous wave. Okay, it seems to be wave, but it is packets. Okay, it has packets of energy. Okay, packets of energy. Okay, but it seems to be wave nature, but it is packets of energy. Okay, packets of energy. It's known as packets of energy. Okay, radiant energy emitted or absorbed by a body, not continuous but discontinuous in these small discrete packets of energy. These packets are called as quantum. Okay, if you increase the temperature of a black body at lower temperature, T1 temperature, it can emit the radiation. It means whenever intensity increases, means goes to from this side, intensity increases means number of packets increases, number of packets of energy emitted energies increases. Okay, number of packets increases, the energy of each packet is also increases. These are 2 points. The number of intensity is increases because number of packets, emitted packets are increases, number of packets comes from the light or increases. Okay, number of packets increases and each packet energy is also increases. That is the reason why you can get the lambda maximum. Lambda maximum means highest intensity at this temperature, and then downs. The intensity of packets or decreases, then it falls. So if we increase the temperature, intensity of the radiation increases means it emits the number of packets are increases. Why intensity increases means number of packets increases and each packet energy is also increases. That is the reason number of packets are increases, goes on, temperature increases, number of packets are increases. Okay, energy of the each packet is also increases, and then reaches maximum and then sharply decreases. Okay. Okay, this is also same thing. Okay, when you increase the further increase of the temperature, so why intensity is very high? Because number of packets of energy is increases and each packet energy is also increases. That is the reason why, and then it is sharply decreases. So in this concept, this practical data is explained by Planck quantum theory in this way. Okay, we know temperature increases, intensity of light is also emitted or absorbed radiation is also increases. Temperature increases, intensity of the intensity is also increases. Temperature increases, lambda decreases, and temperature increases, intensity is also increases. Intensity also increases when increasing the temperature, because number of quanta, number of packets. This means packets are called quantum. Okay, known as quantum. Number of quantums are increases. So that is a reason why intensity is increases. Okay, this is the way he can explain particle nature of the electromagnetic radiation. So packets. Okay, here it's not continuous wave. The emitted radiation is not a continuous wave. It has a packets of energy. Okay, the wave has contained packets of energy. If the packets are increases, the wave packets, energy of the packets in a particular wave, energy of packets is there. The energy of the packets are increases and number of packets are increases. Then intensity of the color is also increases. Okay, you may see any color in VIBGOR. Okay, red color, you know, light red and dark red. Dark red is intense. Intense means number of packets of energy, number of packets are increases, but each packet energy is also higher than compared to the pale red. So in this way you can understand this in a better way. Okay, which is also useful for the physics. Okay, theory which is present in chemistry and which is also present in the physics also. Okay, Planck quantum theory which is also reappears in second year physics, but in first year chemistry, in atomic structure we may learn Planck quantum theory. Okay, which is present in first year chemistry and second year physics. Okay, same concept will appear twice. So if you understand better way in first year, then no need to bother about second year physics. You can understand this concept very easily. Okay, next, second point. In case of light, the smallest packet of energy is called photon. Small packet of energy in case of light energy, you may call it as, in case of light, the smallest packet of energy is known as photon. Small packet in case of light is known as photon, but in general case, smallest packet of energy is called as, known as quantum. In general case it is called as quantum, but in case of light it is known as photon. Okay, photon of light, okay, means packet of energy. Okay, these two and very important points, and there are some more points. We look into this one, and then two more points is present in this in this. Okay, let us see this one. After seeing this, after understanding of these 2 points, then Planck quantum has another 2 points. Okay, the energy of each quantum is directly proportional to frequency of the radiation. Energy of the each quantum, each packet energy of the each packet, is directly, energy of the each quantum is directly proportional to frequency of the radiation. Energy of the each packet is directly proportional to frequency of the radiation. Frequency, this is known as frequency, nu. Okay, nu is frequency. Okay, frequency. Okay. Next, the h means constant. This is known as Planck constant. H is equal to 6.625 into 10 whole to the power of minus 34 joules per second, joules second. Okay, joules second. Okay, next point, total amount of energy transmitted from one body to another will be some integral multiple of energy of quantum. Okay, total energy transmitted E is equal to n into h mu. Okay, there is multiple number of quantums are present. If the total energy contains number of packets of energy, okay, one packet energy is this one, E is equal to h mu. The relation of one packet of energy is like this. There are, if the light has so many packets, then you can apply this one, E is equal to nh nu. Okay, for total amount of radiation emitted. For that one, okay, there is no number of quantums are present. Okay, in this way E is equal to nh mu. N is an integer and n is number of quantum. Okay, this is the way you can understand better this concept. Okay, anything is clear? Let us look into these two problems. One of the problem says, how many photons of light having wavelength of 5000 angstrom are necessary to provide 1 joule of energy. Okay, they ask you how many photons of light having wavelength 5000 angstrom minutes necessary to provide 1 joule of energy. Okay, means you can use this one, E is equal to nh mu. Number of photons they ask you. Energy they have given, number of photons. Okay, n you required, n is equal to E by h mu. Nu is equal to C by lambda. H is Planck constant, C by lambda. Then lambda goes to this one, you can write like this, and then lambda value 5000 10 to the power of minus 10 meters by Planck constant value into C value 3 into 10 to the power of 8 meters second inverse. From that you can get 2.5 into 10 to the power of 18 photons. Okay. Next, calculate energy of photon of wavelength 4000 angstrom units. Okay. Here they ask you energy of a one photon. Okay, energy of one photon is equal to formula, energy of one photon formula is equal to h mu. Okay, you can calculate h and c by lambda. H is constant, c is also constant, then lambda value is 4000 into 10 to the power of minus 10. These two are constants, these values are fixed. H value is always fixed, joules 6.626 into 10 to the power of minus 34 joules second. Okay, C value is also fixed, 3 into 10 to the power of 8 meters second inverse. 8 meters second inverse. So this is also fixed and gives us the 4.96 into 10 to the power of minus 19. From these two problems, why I am saying these two problems, you can calculate one photon energy, and then also you can calculate number of photons in this way. You can calculate one photon energy, one photon wavelengths. In this you can use for this, you can use this formula. You want to know how many photons are present, then you can use this formula. Okay, thank you.